Good morning, everyone. Thank you very much for being over here. And this is really a great honor for us to arrange this. Basically is our first event. And this event in such a great place. It's basically symbolizing Hong Kong over here, as you can actually see the entire Victoria Harbour, all the great stuffs over here. And we want this to be a great start for our journey. And we plan to do it every single year, maybe in different countries and regions, rather than just limited to Hong Kong. But today, what I would like to say over here is that I would like to share a little bit about our journey to build this post-quantum blockchain system. And in fact, I think we just had a very great start of this conference to have those distinguished guests over here giving us a very good background regarding quantum computing and also the post-quantum security. So when we talk about Abelian, this post-quantum blockchain journey, it actually should be dated back to 7 years ago, 2017, actually right here in Hong Kong. And I actually talked to a few of the other founding members of Abelian at that time, and basically we were having some drinks, running a academic conference called Asia Crypt 2017. I think it's December in Hong Kong. At that time, we were running an academic conference, one of the top conferences in cryptography. And we invited international cryptographers, researchers, scholars all over to Hong Kong. And one thing we have been talking about is that what would be the next great thing for blockchain or for blockchain in terms of security, what kind of things that we are missing or what kind of things that we want to do more in order to make it maybe more secure, maybe it's more ready for the future. It's kind of like future ready. And one thing that we have been talking about is how to make blockchain post-quantum, how to make it having the post-quantum security. But at the same time, not just having post-quantum security, we would also like to promote privacy in a sense that which is compliant, but also to protect our individual privacy or enterprise privacy as well. So basically, we are actually giving ourselves like two tasks at the same time. And then the two tasks are, the first one is how to make blockchain post-quantum. What I mean by post-quantum is that we would like this blockchain system to have all the underlying cryptographic primitives to be post-quantum secure. So, for example, like using like lattice-based cryptography or maybe some other kinds of cryptographic systems which are already designed by design, which is post-quantum. So this is the first thing we would like to achieve. The second thing we would like to achieve is that if you think about Bitcoin, we know that the Bitcoin address is not related to our identity, but doesn't mean that when we use Bitcoin to make any payment, we are anonymous, right? Because Bitcoin is traceable, for all our transactions, they can be linked. And also our address, it's not secret. If you send one transaction out, everybody will be able to find your balance of your address on the Explorer right away. So no matter you have just 0.0001 BTC or you have 1 million BTC, everybody can tell. So it's not fully private. So the second task we give ourselves is that how are we going to be able to make a multi-tier privacy, which means one single blockchain system that we can support not just the pseudonymous privacy, which is similar to Bitcoin, but also like fully private, the transaction amount and the wallet balances will all be hidden. And also something in between, like we call it the accountable privacy, which means to the public it's fully private, but how about having a viewing key? So we can actually share this viewing key, for example, with a third party, with authority, so the authority will be able to trace those transactions or see the balance, but you can still keep your wallets private and all that. So we want to achieve all this in one single network which is Abelian. And we basically spent 7 years, continue working on it, and I would consider Abelian right now is just at the very beginning, a very preliminary stage. And we want to work together with everybody to make this more mature and more ready for the next generation, so-called the quantum age. So to look a little bit more into detail of Abelian, basically by design at the very beginning, we pick lattice-based cryptography. In fact, in order to achieve post-quantum security, you have many different ways. Lattice-based, hash-based, code-based, multivariate, you name it. So there are actually many different ways. The reason why we choose lattice-based is because of its mathematical structure, that we will be able to build some of the very elegant, very secure, interesting, we call it the cryptographic primitives, that we can make use of those cryptographic primitives to build different levels of privacy. So for example, when we talk about like digital signature is the foundation of blockchain. Like Bitcoin, Ethereum, they are using so-called ECDSA, elliptic curve discrete digital signature algorithm. So by using the lattice base, we can build digital signature scheme. We can also build some other cryptographic primitives, for example, like zero knowledge proof systems and also commitment schemes, so that we can basically build on top of one single Abelian system with different levels of privacy and some other tools as well. And also one more thing is that we think about when we built this system, we wanted to have a public recognition, the world recognition, rather than just making something out of our research lab and nobody will be able to analyze it. So we try to comply with some standards and we try to do it as much as possible. So that's why we look into the NIST, the National the Institute of Standards and Technology of the States. And actually back to 2016, they already started working on this standardization of post-quantum security. And interestingly, this year, the NIST announced the first batch of post-quantum security standards. And among those standards, we have the lattice-based, basically as the, maybe we call it the winner. So we have like Crystal, Silithium, Falcon, and also we have the Kyber. So basically we have 3 lattice-based crypto systems being standardized. And besides that, we also have a hash-based crypto system being standardized by NIST. But one thing that we shouldn't forget is the SHA-3. So SHA-3, which is a hash function, which has been standardized for a while, and that's quantum resistant, or we believe to be post-quantum. So it's basically an improved version of the existing like hash version, which has been predominantly used, for example, SHA-2. And so basically for Abelian, as you can see, we make use of all the post-quantum cryptographic primitives to build this system, and also to make it so-called scalable enough in the future by building new functions over there. So besides that, I would also like to make a statement. Abelian is kind of like Bitcoin-like blockchain system. Why I say in that way? So actually, if you check out the tokenomics and also the structure of Abelian and compare that with Bitcoin, we have actually a lot of similarities. And of course, there are a lot of reasons behind this kind of design. The first one is that it's proof of work. So in fact, in terms of the decentralization, as well as the security, POW actually gives you a lot of great advantages when you compare with other consensus protocols. For example, like POS or like proof of authority and all that. So basically, we stick to POS because of security as well as decentralization. The second thing is that if you just think about proof of work, you can have different kinds of ways to do it. For example, like Bitcoin right now is predominantly using those ASIC machines to do the mining. But actually for Abelian, interestingly, it's not quite like Bitcoin yet. We promote a lot about GPU mining here because basically as soon as you have GPU cards, you can just spin it up. If you are not playing games, you can actually use it to mine ABELs. So it actually gives us greater decentralization rather than just being controlled by those ASIC manufacturers. Like if you just think about those ASIC manufacturers, you don't have a lot. But doesn't mean that we are against ASIC. We think that that's basically a journey. For now, at the very beginning, actually our live network basically went live back to 2 years ago. So right now it's still at a very early stage. We would like it to be as decentralized as possible. But down the road, when it's getting more and more mature, I think it makes sense to have the ASIC machines to do the mining as well because of the lockdown over there and also the commitment to the stability of the system as well. So that's why at this moment I have to say the GPU mining by design gives you the highest return. So it's also very similar to the Bitcoin. We have like every 256 seconds, we have one block out, 256 ABELs out. But there will be the first halving coming up very soon. So it's very similar, like every 3 years, 3.25 years, we have one halving coming up. So I'm actually looking forward to that month. We don't have an accurate estimation about when exactly, which time or which day it will happen, but the estimation is going to be getting more and more precise when we get close to May 2025. So I'm looking forward to that. Right now, every day, there are about 80,000 ABELs mined. So by that day, it's going to be reduced to 40,000. Right? So besides the post-quantum security, another part I emphasize a lot is about the privacy part. So about the privacy, as I mentioned, if you look into Bitcoin, I call it having the pseudonymous privacy protection. Pseudonymous is traceable, and also all the balances are public, and it's pseudonymous because the address is not linked to your ID. But actually, if you compare that one with your bank account is not called pseudonymous, right? Quote-unquote big brothers will be able to see your balance and know all your transactions. But doesn't mean that the public will be able to know every single transaction of yours. So I call it a semi-private over here, just a name for the convenience of the presentation over here. But actually, a lot of people are actually saying that Bitcoin is a digital gold. Why? Because it has the value, it has the limited supply, 21 million. But if you actually compare with the nature of gold, actually there is a huge distinction between the physical gold. I'm not talking about the paper gold, but the physical gold that you hold it on hand, and the Bitcoin. It's not about whether it is tangible or not. It's about your privacy. So if you have some gold, doesn't mean that the amount of gold or the weight of the gold is public, right? It's private. But for Bitcoin, we cannot achieve that because your wallet will be out. If you send one transaction out, your wallet address or the public key is actually on the ledger. So it's actually not as same as the physical gold. A physical gold, I don't need to worry about like how many people will be able to know how much gold I'm holding. But for Bitcoin, well, my wife or my kids, they know my address, so they know how many tokens I have. So for Abelian, what we would like to achieve, and we have already achieved, is that we have full privacy by default, which means no matter how many times that you send the tokens out, your public key and also your addresses will remain private. So we make use of some technologies like link-boring signature to hide your addresses, and your addresses will actually keep refreshing to new ones. So there's no one single address being used indefinitely. And also the transaction amount is all hidden every time when you send things out. So when we talk about Abelian privacy, we actually talk about not just one level of privacy, but actually we are talking about maybe 3 basic levels. We can actually have more levels, but right now we are talking about 3 basic levels first. The first one, as I mentioned, is the pseudonymous one, which is the same as the Bitcoin one. The second one, which is another extreme, which is kind of like fully private, kind of like maybe Monero or Zero Cash, but in the post-quantum security level, which means the balance and also the transaction will all be untraceable and will be hidden. And then the third level, I call it the accountable one, the accountable or the semi-final one, a semi-private one, which basically means that for the public, from the public's perspective, it's fully private. You will not be able to find anything, the balance, the transaction. But there is a viewing key that you can actually share with a third party. So for example, like in the future, while the regulatory framework in Hong Kong is getting more and more mature in term, for the crypto, we might need to share maybe the viewing key, maybe with the exchange, for example, or maybe with your custodian entity. Then you can basically share that viewing key with those entities. But they will not be able to control or find out basically they cannot control like sending the transactions. And also the public will not be able to find out your balance. Only those entities that you share the viewing key will know the balance or the transaction. Or another thing is that you can freely transfer those tokens from one type of address to another. Like for example, if you already have some tokens in your fully private wallet, you can freely transfer it to a pseudonymous wallet. Once you transfer it to the pseudonymous wallet, you can gain the speed, and also you can also, for example, like comply to some other kinds of requirement or the regulatory requirement. So you can actually try out all this using our wallet, and we are also building some more user-friendly wallets for non-technical folks to have a try. So when we talk about blockchain, we always talk about the trilemma: decentralization, security, as well as scalability. So when we talk about Abelian, we definitely focus on the decentralization and security. But how about scalability? So right now, like Abelian is very similar to Bitcoin. And if you think about Bitcoin, the scalability part, we are just talking about like 7 to 10 transactions per second. So it's basically not very suitable for many other kinds of application. So how do we solve this problem? So for example, Abelian, we can support like 20 to 30 transactions per second, but definitely it's not good for, say, other applications, say, stablecoins, right? So our approach is this layer 2, which is called QDay. So Q stands for quantum. So layer 2 is basically sitting on top of Abelian chain. And then this layer 2 supports the EVM equivalent smart contract. So basically, you can just run your existing smart contract that you developed for Ethereum or the Ethereum ecosystem on top of QDay. And also, it's much faster. So our testnet is actually out. And it's very easy to achieve 1,000 transactions per second. We can actually improve that further by fine-tuning it. And also, in addition to this fast transaction, the gas fee is much lower. And also, very importantly, we have this serial knowledge rolled up to connect the Abelian layer with this QDay. So for all the transactions and smart contract on QDay, they are basically compressed. And then the so-called message digest is written onto Abelian in order to make sure QDay is also quantum resistant. So this is basically the first step, that this is actually the world's first quantum resistant smart contract blockchain system. I consider this as our first step because what we have already achieved right now is a smart contract post-quantum blockchain, but it's not real time. So next thing is to make that real time by introducing post-quantum wallets onto QDay so that you can have quantum resistant wallet directly onto QDay rather than using any of the existing, for example, like elliptic curve signature scheme. So this is what we are currently building. And if you want to try it out, you can actually try out our testnet. The testnet is already live. And another exciting thing is that we are going to launch the ABEL staking very soon. So next quarter, we are going to have this staking, which means this is basically the only way for you to get the QDay token. Whenever you have ABEL tokens, you can stake that, and then you can earn the QDay tokens. And then later on, we will also have the DeFi as well as the DEX. But if you want to try out some of the DeFi applications, you can actually already try it out on the testnet. It's already there. So to sum up, kind of like a brief introduction about Abelian. Abelian is the first and also the only privacy-preserving post-quantum blockchain system nowadays. So we spent these 7 years doing the research and development, and we will continue building on top of it, mainly using some post-quantum zero-knowledge proof to continue adding different kinds of privacy layers over there, in addition to the 3 layers, and also to improve the efficiency and continue improving the security, and working with all those professors, scholars, and also practitioners to further enhancing this position. Besides that, our approach is called a 2-layer approach. So the first layer is the Abelian, and this layer provides decentralization and post-quantum security. And the second layer, which is the QDay, offers smart contract as well as scalability. So in addition to that, look forward to having our ABEL staking. So very soon we are going to have this ABEL staking. And also very soon we are going to turn this testnet into a live network of this QDay. So looking forward to that. Again, thank you very much for coming over here. Thanks for your time. Yeah, thank you very much.
All right, thank you very much, Duncan. Sir, please can you be seated?